Okay, boys and girls, so this is the C1 2015 paper. So, the first question we've got to do is to expand these brackets. Now, obviously, if you're going to have square brackets, what you need to do is just multiply the brackets by themselves. So you write out the bracket twice. So we're going to have 2 root 5 times by 2 root 5. So you can write 2 root 5 as 2 times root 5 times by 2 times by root 5. And then multiplication is commutative, so it doesn't matter which order you do it. So you can do the 2 times 2, which makes 4. You can do root 5 times root 5, which makes 5. So you've got 4 times 5, which equals, of course, 20. Right, so the next thing we've got to do is we've got to rationalize this thing here. So if ever we've got a fraction with square roots on the bottom, if it's in this format, if it's just something over the square root of 3, you times top and bottom by the square root of 3. However, this question here is different because you've got a square root minus a square root. And if you have this case, then what you've got to do is you've got to multiply by what's called the conjugate. So you've got to multiply by the bottom, just switch the sign around. So you're going to have root 2 over 2 root 5 plus, 2 root 5 minus 3 root 2. Then you multiply top and bottom by 2 root 5 plus 3 root 2. 2 root 5 plus 3 root 2. If you put those in brackets, and then you just multiply out. So you do root 2 times 2 root 5, you do root 2 times 3 root 2, and then on the bottom you do the smiley face method. So if we do that, we're going to get 2 root 10 plus 3 root 2 times root 2 is going to be 3 times 2, which is going to be 6. Okay, so then if we do the left eyebrow, 2 root 5 times 2 root 5, we've done that before, and we've got 20. We do the right eyebrow, so minus 3 root 2 plus 3 root 2 is going to be minus, and that's going to be 3 times 3, which is 9, root 2 times root 2, which is 2, so it's going to be minus 18. And then with all these questions, you've got the thing that cancel out. So you've got the minus 6 root 10, then you've got the plus 6 root 10. So those two are going to cancel out. So what you end up with is 2 root 10 plus 6, and 20 take away 18 is going to be 2, which you then cancel down to 6 plus, sorry, not 6, 3 plus 1 root 10, which is in this format here. Then if we double check our answer, we've got 20 for part A, and part B, 3 plus root 10. Hooray, so we're off and running with 5 marks. Okay, so bringing us up to 12 marks, we've got question 2, and it's solve simultaneous equation. So when you've got this simultaneous equation, if we're substituting it into something with either an x squared or a y squared, we need to use the substitution method. So we've got to rearrange to get either y equals or x equals. So rearranging this, we've got y equals 2x plus 4. Then we substitute that into this one here. So we've got 4x squared plus 2x plus 4 squared plus 20x equals 0. Now, as I've said many, many times, if ever you've got a bracket squared, you need to get rid of the squared and just write the bracket out twice. And then again, just like the last question, use the smiley face method to multiply that out. So by doing that, 4x squared plus, you got 4x squared plus 16, and you add both those as plus 8x plus 8x. It's going to be plus 16x plus 20x equals 0. Then if you gather together, that's going to be 8x squared plus 36x plus 16 equals 0. And we see that 4 goes into everything there, so that's going to be 2x squared plus 9x plus 4 equals 0. And then you've got to factorise. So 2x times x makes 2x squared, and you need to put the 1 in the first one and the 4 in this one, so that when you multiply those out, it's going to be x, and that's going to be 8x, which adds together to make the 9x. But we've got to solve, so the two solutions are x equals minus a half, and x equals minus 4. And of course, with simultaneous equations, what you've then got to do is you've got to find out the corresponding values of y, and we substitute that back into this one up here. So 2 lots of minus a half is going to be minus 1, plus 4 is going to be 3. 2 lots of minus 4 is going to be minus 8, plus 4 is going to be minus 4. And again, if we check the solutions, we get x is minus 4 and minus 0.5, and y is 3 and minus 4, which thankfully is what we've got. So that's 12 marks off the first 2 questions. Then they've given us some reasonably straightforward differentiation questions. So if we've got y equaling 4x cubed minus 5 over x squared, we've got to put that into a form that we can either differentiate or integrate. So we bring the x squared up to make x to the minus 2. So dy by dx equals 12x squared. We bring the minus 2 down when we differentiate, so that's going to be plus 10x to the minus 3. We can leave it like that, or if we wanted to, we could bring the x underneath, because x to the minus 3 is the same as over x to the power of 3. So that's part A. In part B, we've got to integrate it. So if we've got 4x cubed minus 5x to the minus 2, we're going to integrate it, and we get 4x to the power of 4 over 4 minus 5x to the power of minus 1 over minus 1. Just be careful with this, because it's easy to make mistakes when dealing with negative numbers, but when you add 1 to minus 2, it's going to go up to minus 1. And then, of course, what you need to remember each time when you integrate is the plus c on the end. And a good rule of thumb is that if you haven't put the plus c, get someone to punch you in the arm each time you forget it, so that in due course you no longer forget. So you simplify then, 4 over 4 just makes x to the power of 4. If you've got a minus divided by a minus, that can be a plus, so that's plus 5x to the minus 1, or 5 over x, plus c. Which again, if we check 12x squared plus, they've put it as 10 over x to the power of 3, but if you have a look at the mark scheme here, it says that you can have plus 10x to the minus 3, and that's absolutely fine. And then the answer for this one, x to the power of 4 plus 5x minus 1 plus c. So huzzahs, 18 marks. We're getting close to that 30 marks, which is 40%, which is where we can start thinking about grades. So, question 4, recurrence relations. Now, the thing with the recurrence relations is understanding what the n's, the n plus 1s, and the n plus 2s mean. So, if this is any term, doesn't matter which term, could be the first term, could be the 100th term. If we've got n, then n plus 1 is the term after that one. So, if you're looking at the 150th term, if this is a 150th term, this one would be the one after it, so 151st term. This would be the one after that, which is 152nd term. So if we're told that u1 here is 4 and u2 is 4, then we're saying that un, so this is the first term, this is the second term, so this is going to be the one after that. So if we're looking for the third term, then it's going to be, so the third term, which we're going to write down as un plus 2, equals 2 lots of un plus 1, which is the term before that one. So it's going to be 2 lots of u2, which we know is 4, take away un, which is the first term. So 2 lots of 4 take away 4 is going to leave us with 8 minus 4, which equals 4. That's only 1 mark. So what we've got to do is then we've got to add up the first term through to the 20th term. So we know that u1 equals 4, u2 equals 4, u3 equals 4. I think we've seen a pattern here. And just to double check, see if it does carry on, then okay, so if we've got 4 equals 4, 2 lots of 4 take away 4, this will always be 2 lots of 4 take away 4, because the previous terms are always going to be 4. So if we've shown that before, that equals 4, then the next time it's going to be 4 as well. So all the way through from U1 up to U20, all of them are going to be 4. So in essence, what we have here is this is saying we've got the first term up to the 20th term, and they're all going to be 4. And this sigma here means that we're going to add them. So we're going to add 4, 4, 4, 4. So we're going to add 20 lots of 4, leaving us with 80. And you're going to get 1 mark for saying that, 1 mark for the 80. Okay, part 2. We've got to find V3 and V4 in terms of K. So we've got V1 and we've got V2, and just like before, we've got a term here, so whatever term that is, we've got the term after it, so it's 2 lots of that term, and that equals the term after that one. So to get V3, we're going to do 2 lots of the term before it, so it's going to be 2 lots of V2, which we know is 2K, take away the one before that one, so take away V1, which is going to be K. So V3 equals 4K, take away K, so that's going to be 3K. V4 equals, so if we now treat this one here as the 4th term, that's going to be 2 lots of the 3rd term, take away the term for that, which is the 2nd term. So that's going to be 2 lots of the 3rd term, which we know is 3K, take away the one before that, which we know is 2K. So we've got V4, 6K, take away 2K is 4K. Now just to make sure that that works, and that 3K and 4K gets us the 2 marks here. So let's have a look at V5. So that's going to be 2 lots of the term before, which is going to be 4K. Take away the one before that, which was 3K. So that's going to be 8K, take away 3K, which equals 5K. Now the reason I found V5 as well is because if we have a look at this thing here, let's try and understand what this means. So from n to 1 up to 5, that means you're going to look at the 1st, 2nd, 3rd, 4th and 5th term of this sequence. Now the sequence here just says V, so it means that if we substitute in 1 up to 5, we're looking for V1 plus V2 plus V3 plus V4 plus V5, and that's just by substituting 1 into where it says n. So that's V1, then we substitute in the next one, which is 2. And if we add them all together, that's what we get here. And it tells us that if we add all those together, we get 165. So if we are thorough with this and we write out our workings, we do V1, which was K, plus V2, which was 2K, plus V3, which was 3K, 4K and 5K, and that all adds up to 165. So to find out what the value of K is, we simplify this. So that's going to be 3K, 6K, 10K, 15K. 15K equals 165. So K equals 165 divided by 15. Well, know that 10 15s are 150, so 11 15s must be 165. So K equals 11. And again, if we check our answers, K equals 11. Hooray! Okay, question 5. So it says we've got an equation and no real roots. So as soon as you see something which mentions roots, whether it's real roots, equal roots, or just the word roots, we're going to have something to do with b squared minus 4ac. Now if it says no real roots, that means it's going to be less than 0. If it says equal roots, then b squared minus 4ac equals 0. If it says has 2 distinct real roots, then it's going to be greater than 0. But here it says it's got no real roots, so we say that our discriminant, b squared minus 4ac, is less than 0. So this thing here is a, 4 is b, and this thing here, including the sign, equals c. So we've simply got to substitute these into our discriminant function here and set it less than 0, and that hopefully turns out to be this thing here. So b squared is going to be 4 squared minus, then I'm going to put this in brackets, 4 times by a, so 4 times by p minus 1, times by c, which is the other bracket, p minus 5, and that is less than 0. So let's simplify that. 16 minus 4 lots, so then if we multiply the brackets using the smiley face method, p squared plus 5 minus 1p minus 5p is going to be minus 6p is less than 0. And again, there's no shame in taking that up more lines of workings than you think you need. Just make sure you're thorough with it. So if you multiply the inside brackets again, 4p squared plus 20 minus 24p is less than 0. And then, because we've got the minus in front of this bracket, and again, this is why I said put it in brackets, the 4ac in brackets, because it's very, very easy to make mistakes with the signs. And if you find that you have made mistakes with the signs, scrap it, go back and start again. I mean, you should have plenty of time with C1. But don't just try and change the sign and hope that the examiner won't see, because the examiner is paid to find out where you've dropped marks. So if you feel like you're trying to fudge it a little bit, go back and really try and find out where you've made the error with the sign. And again, go back, make sure you put it in brackets, and then work through it thoroughly. So going back to this point, we've got a minus in front of this set of brackets, so this minus here means that we're going to change the sign of everything inside the brackets. So we've got 16 minus 4p squared minus 20 plus 24p is less than 0. So then let's simplify that. 16, so that's going to be minus 4p squared plus 24p. And 16 minus 20 is going to be minus 4, and that is less than 0. Now we've got a choice here. We can either bring everything over to the right-hand side, but because we've got minus 4p squared, that means we want to make it positive, so we bring everything over to the other side, or you can multiply by minus 1. Now, here's the thing that everyone forgets. When you multiply by minus 1, the sign here of the inequality switches direction. So whenever you multiply or divide by a negative, the inequality sign, it changes direction. So we're going to make that 4p squared minus 24p plus 4 is greater than 0, which is why in the answer over here, we've got it as greater than 0. Then we just simply divide it through by 4 to get p squared minus 6p plus 1 is greater than 0, which is exactly what they wanted us to show here. So once you've done that, it says, hence find a possible set of values for p. Now the good thing about this is that even if you wasn't able to do part A, and we can give part B a good go. Now, just looking at the bare bones of it, what we've got here is that we've got a quadratic inequality. Now, whenever we've got a quadratic inequality, we sketch it, and then we find where that sketch is greater than 0. I can't underestimate that enough. A lot of people just solve it, find out the two points where it goes through the x-axis, or find the two solutions of p, and then put two inequalities that relate to those things there. I know you could possibly visualize it in your head, but make sure you do the extra workings anyway. What we're going to do is we're going to sketch what this quadratic looks like. So along the p-axis here, and it doesn't matter what we call the y-axis, let's just call it y. So let's sketch out what p squared minus 6p plus 1 looks like. So if we do factorize it, it won't factorize. So what do we do if a quadratic doesn't factorize? We can do one of two things. We can either do completing the square, or we can use the formula. So let's use, in fact, let's do both. So if we do completing the square, that's going to be p minus 3 squared, take away 9 plus 1 is greater than 0. Well, if we set it equal to 0. So p minus 3 squared, if we bring the others over to the other side, that will equal 8. So then p minus 3 equals plus and minus the square root of 8. So p equals plus minus, so if we add the 3 over, 3 plus and minus the square root of 8. Now the square root of 8 is the square root of 4 times the square root of 2, so equals 2 root 2. Or alternatively, if you don't like using completing the square, and I know some people don't, then you can use a quadratic formula, which is minus b plus and minus the square root of b squared minus 4ac equals 2a. And again, if you've got time at the end of your exam, try using both methods just to make sure that A, you do some practice for C2, but also that you can use both methods and that you get the same correct answer. So B is going to be minus 6, so minus minus 6 is going to be 6 plus minus the square root of b squared, so that's going to be 36 minus, then in brackets, you always put 4ac in brackets, 4 times by 1 times by 1, that's all over 2a, so that's all over 2. So let's go back up here. So that's going to be 6 plus and minus the square root, and if you do the square root of 36 minus 4 times 1 times 1, it's going to be the square root of 32 over 2. So if we do this, that's going to be 6 plus and minus the square root of 16, the square root of 2 over 2. So square root of 16 is just 4. So if we divide everything through by 2, we get 3 plus and minus 2 root 2, which is no coincidence, is exactly the same using both methods. So where this goes through the x-axis, it's going to be this thing here, which is 3 plus 2 root 2, and 3 minus 2 root 2. And we know that it goes through at plus 1. It doesn't matter how accurate this diagram is. As long as it looks something like this. Now, what we've done, so what we've got to do is we've got to find the set of possible values that make this true. So we need to find the values of p that make it greater than 0. So we have a look, and where is our graph greater than 0? This bit here is above the y-axis, this bit here is above the y-axis. So the final answer is when p is greater than 3 plus 2 root 2, and this bit here, which is where p is less than 3 minus 2 root 2. And again, that question starts to get a little bit tricky. Okay, let's have a look at question 6. Okay, so question 6, and before we do question 6, just because I know he's going to be looking for it in this video, I've got a little shout out to Harry, who brought to the attention Unicorn King's comment of, hey, that's pretty good. Well, Unicorn King, hey, we think you're pretty good as well. Okay, so question 6. The curve has this equation. We've got to find dy by dx. Now, in every single one of these types of questions, before you can do dy by dx, we've got to get it in a form, or whether we integrate as well, we've got to get into a form where we can actually integrate it. And here, it's an absolute car crash. We can't integrate it at the moment. We've got to simplify it. So we're going to use a smiley face method to multiply it out, and then we're going to divide. Then we're going to split it into 4 different parts and divide each of those parts by 2x. So y equal, if we multiply it out, we're going to get x cubed minus 3x squared plus 4x minus 12. And then what we're going to do is we're going to split that up into all 4 fractions. So it's going to be x cubed over 2x minus 3x squared over 2x plus 4x over 2x minus 12 over 2x. Okay, so then if we cancel that, y will equal, get rid of the x there, get rid of one of these x up here, so that's going to be x squared over 2. Get rid of an x there and x there, that's going to be 3x over 2. Get rid of an x there and x there, 4 divided by 2 is going to be just 2. And we're going to bring the x up to the top. Also, 12 divided by 2 is going to be 6, so it's going to be 6x to the minus 1. And then we differentiate it. So dy by dx will equal 2x over 2. The x is just going to go, so that's going to leave us with 3 over 2. We're going to bring the minus 1 down, so it's going to be plus 6x to the minus 2. And then it says in its simplest form, so we're going to then simplify that. So it's going to equal x minus 3 over 2 plus x over, so 6 over x squared. Okay, so up here we've got dy by, if we write out our answer up here, so we can use the space again, x minus 3 over 2 plus 6 over x squared. Okay, the next one, find the equation of a tangent to the point where x equals minus 1. So as soon as it uses the words find an equation of a normal or find an equation to the tangent, the first thing I would always do, y minus y1 equals mx minus x1, because I know that as soon as I start using that, I'm going to start to get some marks. And so we need to have two things if we're going to use this. We need to have the gradient and we need to have a coordinate. That gives us the x coordinate, but it doesn't give us the y coordinate. So what we need to do to find the y coordinate is we need to substitute it into there. So y equals minus 1 squared is going to be 1, plus 4, that's going to be 5. Minus 1 take away minus 3 is going to be minus 4. Divided by 2 lots of minus 1, so it's going to be divided by minus 2. So it's going to be minus 20 over minus 2, which equals 10. So minus 1, 10 is the coordinate, and we also need to know the gradient. And so to work out the gradient, we substitute our value of minus 1 into our gradient function. So that's going to be minus 1 take away 3 over 2 plus 6 over minus 1 squared. So that's going to be 6 over 1, which is just 6. So we've got dy by dx equals minus 1 minus 3 over 2 plus 6. So that's going to be 5 take away 3 over 2, or 5 take away 1 and a half, which is going to be 3 and a half, which equals 7 over 2. So 7 over 2. And then we've got to write it in this format here. So if we then use this here, we've got y minus y1. y1 is 10 equals m, which is 7 over 2, x minus x1, so that's x minus minus 1, so that's going to be x plus 1. Now when we've got a fraction and it wants it in the form ax plus by plus c equals 0, we get rid of this divided by 2 by multiplying the other side by 2, and then we're going to multiply out the brackets. So if we bring the 2 up, that's going to be 2y minus 20 equals 7x plus 7. And then they want everything on one side and set it equal to 0. So it doesn't matter, you can bring it to either side. My personal preference is to keep the x positive. So 7x minus 2y, if we bring the minus 20 over, you need to add it on, so that equals plus 27 equals 0. And just because I'm prone to making mistakes, I'm going to just double check that. That's the previous answer, 3 minus root 8 or 3 plus root 8. And again, you could have had done that as plus or minus 2 root 2. So 2, 1 minus 7x minus 27 equals 0. So yeah, they've got it where y is positive. But if you change both those signs around, we see that we get this here. So it doesn't matter which way round that you have that. Okay, so let's have a look at question 7 now. Right, Right, now this one's done notoriously badly. So you know that y equals 2x, and you've got to express 4 to the power of x in terms of y. Now you get questions like this in terms of logs and exponentials in C2. So we've got to get it looking like 2 to the power of x, but we've got 4 to the power of x. What we can say though is 4 to the power of x is 4 is the same as 2 squared. So 2 squared to the power of x is the same as 4 to the power of x. Now what we do is when we've got two powers and they're in brackets, we can multiply those together. So we can say that's 2 to the power of 2x. But again, it doesn't look like 2 to the power of x. So if we can multiply the powers from the brackets, therefore we can factorize this by saying 2 to the power of x squared. So 4 to the power of x is the same as 2 to the power of x squared, and we know that 2 to the power of x is y, so that simply equals y squared. Now it's only 1 mark, so it's not a tragedy if you don't get it, but you kind of need it for this one here. And the thing, you can actually help B to give you a hint on how to do A. Because if you have a look at this here, you've got 8 lots of something, take away 9 lots of something, plus 1 equals 0. And especially if you've seen it a few times, you can tell that looks like a quadratic. So with a quadratic, you tend to have this thing here is something squared, something lots of x, and then you've got the plus number on the end. So chances are this is going to be something squared. And if you know that this one here is y equals 2x, and that's going to be minus 9y plus 1 equals 0, you should be able to see that this is going to be the y squared, so it's going to be 8y squared. And you don't use that as a guarantee, but it should help you out anyway. So, okay, now we need to factorize that. So, if we factorize that, and again, it doesn't matter how quickly you factorize it, you've actually got just over 6 minutes to do this question. In fact, now you've got 6 minutes dead to do this question. So if we do that, it's going to be minus y and then minus 8y. So we've got the two solutions, y equals 1, and then 8y equals 1. So you've got y equals 1/8. But we've got to solve, so we don't want to know what y equals, we want to know what x equals. So we know that y is 2 to the power of x, so we can actually rewrite that as 2 to the power of x equals 1, and 2 to the power of x equals 1/8. So the first one here, 2 to the power of something equals 1. Well, all the way through GCSE, you should have known that anything to the power of 0 is 1. It's like one of those one marker gimme marks. So here we've got x equals 0. So we've got 2 to the power of something equals 1/8. So we should know that's going to be a negative power. So x is going to equal minus. So as soon as you've got 2 to the power of minus something, that's going to be 1/2 to the power of something. So 2 to the power of something is 8, so that's going to be 2 to the power of 3. So that's 2 to the power of minus 3. So x equals minus 3. Again, not a straightforward question, but even if you spot here that this thing here is a quadratic, and that could help you to get the first mark here, and also you can start to factorize it to get some marks as well. So again, it's not necessarily about getting 100%, it's about getting enough marks so that we get our target grade, either an A, B, C, or whatever it needs to be. And again, remember C1 is the one that you've got to be aiming for more than your target grade, because C2 will be harder. Okay, next one. Now this one is often a question 1 on the first part of it because it comes up so frequently, and it's factorized completely. So factorized completely means that it's going to be more than one step, especially when it's more than 1 mark. And if ever they give you a cubic, i.e. something to the power of 3 in C1, it means the first thing we do is we factorize out the x, and then we've got a quadratic to factorize. So if we do that, we take out an x, and that's going to be 9 minus 4x squared. And then we've got to put it into two brackets, and so it's a matter of spotting that this thing here is the difference of two squares. So something times something is 9, so that's going to be 3 times 3. You're going to have a plus and a minus. Something times by itself is 4x squared, so it's going to be plus 2x and minus 2x. So that's the first 3 marks, and that should be sort of relatively straightforward. Next, we've got to sketch this curve. So we've got to sketch y equals that there. So if we're going to sketch that, I'll do a sketch up here. Obviously, you do it in a little bit bigger. So we need to find out where this goes through the x-axis. So it's going to go through the x-axis at 0 there. It's going to go through at minus 3 over 2. And it's going to go through at 3 over 2. So 3 over 2 and minus 3 over 2. And we can see that it's a negative, and this is the bit where people may lose marks. It's the fact that you've got a minus x cubed, which means it's not going to be a normal cubic, it's going to be a negative cubic, so it's going to look like that. So it's going to be a negative cubic, which goes through the x-axis at 3 points here. And again, if you wanted to double check where it goes through the y-axis, you set x equal to 0, and if you set x equal to 0, y will equal 0 here. And so we know that it goes down through there, up through there, and down through there. And you might need to just say that it goes through at 0 as well. Sketch your coordinates, so 0, 0, just as overkill, that 0, and that 0. Okay, so we now know that the points A and B lie in the C and have the x-coordinate of -2 and 1 respectively. So let's work out what the y-coordinates are. When x equals -2, 9 lots of -2, so y equals 9 lots of -2, which is -18. Take away 4 lots of -2 cubed, so -2 cubed is going to be -8. So -4 times -8 is going to be +32. So it's going to be -18 plus 32, which equals 14. So we've got the coordinate -2, 14. And then we've got to substitute 1 in there. So x equals 1, and y equals 9 take away 4 lots of 1 cubed, so that's going to 9 take away 4. So y equals 5. So 1, 5. And then what we've got to do is we've got to find out this length here. Okay, so we've got to find the distance between two coordinates. And so the way we do this, if we want to sketch out another sketch just to definitely see what we're looking at, we've got two coordinates. We've got -2, 14, and again, it doesn't need to be accurate, -2, 14, and 1, 5. So to work this out here, we use Pythagoras. So we look at the change in height and the change in horizontal distance, make it a right angle triangle. So this is -2 across, and this is 1 across. So that's going to be a horizontal distance of 3. This one here is 5 up, this one up here is 14 up, so that's a vertical distance of 9. So the length AB is going to be the square root of 9 squared plus 3 squared. So that's going to be the square root of 81 plus 9, which equals the square root of 90, which if we simplify that is square root of 9 times by the square root of 10, which equals 3 root 10, which again looks like something root 10, so therefore we can be pretty confident that we've probably got our answer correct. So again, if we just double check, -3 and 0 were correct for question 7. Um, yep, that one looks correct. And hooray, we got 3 root 10 down there. So job's a good one. So yeah, again, getting 10 marks towards the end of your C1 paper is only going to help you get your high grade, because they tend to put the tricky questions at the end, as you'd expect. Right now, again, people don't like these questions because they're wordy. So in order to try and combat that, what I tend to do is just write down basic piece of information so that we just work with that. So just so I worked 20 years ago, in her first year, her annual salary was 17,000. So I'd immediately write down that A equals 17,000. Her annual salary increased by £1,500 per year. So D equals 1,500. And so then they say it goes up by 1,500, goes up by 1,500 again, forming an arithmetic sequence. It's continued until she reached a maximum annual salary of 32,000 in year K. Her annual salary then remained at 32,000. So find the value of the constant K. So if we write down the A plus N minus 1 D, that's to work out any terms, that's to work out like the nth term. And just that we've got it written down somewhere, um, n over 2 bracket 2a plus n minus 1d, that's how to work out the sum of any series. Because you can also have n over 2a plus l, and that works as well. So what we've got to do is we've got to work out in which year she got 32,000. So I'm going to write down that 32,000 is going to be her initial salary, which is 17,000, plus k minus 1, because instead of the nth term, we look at the kth term, times by 1,500. So, then what we do is we take away 17,000 from both sides. So we've got 15,000 equals k minus 1 times by 1,500. So they've been quite kind here with the numbers. If you divide by 1,500, we're going to get 10 equals k minus 1. So if we then add 1, k equals 11. So in the 11th year, she's got 32,000. Now, we've got to calculate the total amount that Jess has earned in her 20 years. Now, again, this is almost a trick question because they've given you an arithmetic sequence question here, and you've got to work out the total amount. So the first thing you think of is, okay, this thing over here, this works out the sum of my sequence. I know that n equals 20. I know that the value of A is this. I know that D is this. However, this is where you need to stop for a second and just think it through. The fact that they've said the annual salary then remained at 32,000. Again, this is what's going to separate the A grade students from students that end up getting C's and B's. Because if we have a quick look at what's happening here, we've got 17,000. Next year you got 18,500. Then you got, so that's the first year. Second year, third year is 20,000. Fourth year is whatever that turns out to be, up to the 11th year, where the 11th year is 32,000. Then you've got the 12th year, which again stays at 32,000. So it's no longer an arithmetic sequence. So what we've got to do is we've got to work out the sum up to this point here, and then we're going to have however many lots of 32,000 after that. So let's start by doing that then. So what we're going to be using is n over 2, 2a plus n minus 1 lots of d. So what we can do is, because in the 10th year, she earned 30,500. So we've got a choice. We can either add up what she got in the first 10 years using this thing here, then add on the 11th, 12th up to the 20th year, and then add those together, or we can work out what she got in the first 11 years, because that's still an arithmetic sequence, and then work out what she got in the 12th, 13th, 14th, all the way up to the 20th year. And it's completely up to you. I mean, there's sort of benefits and drawbacks of doing both. I am probably going to do the 11th year. So that when I do n minus 1, I've got a nice round number as 10. Of course, if you do the 10th year, then 10 divided by 2 is going to give you 5, not 5.5. So again, it doesn't really matter, but for this question, I'm going to use n equals 11. So I'm going to work out how much you got in the first 11 years. So if we do that, that's going to be 11 over 2. 2 lots of 8, so that's going to be 34,000. Plus n minus 1, so that's going to be 11 minus 1. Lots of the difference, which is times by 1500. So that's 11 over 2, 34,000 plus 10 lots of 1500, so that's going to be plus 15,000. So that's 11 over 2 times by 49,000. So 11 over 2, rather than doing 5.5 lots of this, I'm going to divide this thing here by 2 and then times it by 11. So I'm going to do 24,500 times by 11. So if I do that, it's going to be 0.00542, then 10 lots of it, which is 0.00542, which gives me 0.05962. So in the first 11 years, she earns what have I written down? 269,500. 269,500. And then we've got the 12th year, 13th year. So count on fingers, 12th year, 13th, 14th, 15th, 16th, 17th, 18th, 19th, 20th. So it's going to be 9 years. So plus 9 years at 32,000. And of course, I'm notoriously bad at making mistakes, so I'm going to double check my answer afterwards. But I need to do 9 lots of 32,000. So times by 9, so that's going to be 0.00018. 3 lots, so let's carry the 1. 3 lots of 9 is 27, plus 1 is 28. So it's going to be 288,000 plus the 269,500, so 0, if we add those together, 0.057, carry the 1, 5, carry the 1, 5. So 557500. And dear Lord, I hope that's correct. Yes, it is. 557500. Of course, I was entirely confident of that. I was just making you guys feel better. So, question 10, which I believe is our final question. So this is it. We get to this point and we're confident, especially on that last question, question 9, that we've got 100% up until this point. So we don't want to let it drop here. So the first thing is being able to recognize this question. So we've got, so the first thing we've got here in our question is we've got f dash of x. We've got the gradient function that asks us to find f of x, and it also gives us a coordinate. So when we do this question, we've got to integrate it to find fx, and then we've got to get rid of that plus c by putting in this coordinate here. So it's a matter of recognizing this type of question. They give you the gradient function, they ask you to find the function of the graph, and they give you a coordinate. So we've got to integrate it, and then we've got to find out what our value of c is. And again, just like beforehand, when we integrate it, we can't have this square root of x on the bottom. We've got to bring it up to the top and make it x to the minus a half. And again, we can't have square root of x. We've got to have that as x to the power of a half. So f of x, if we integrate that, that's going to be 3x. So that's 2's on the bottom. So that's going to be 3x to the power of 3 over 2 divided by 3 over 2 minus 9, so 4's on the bottom, 9x to the power of a half divided by a half, so the half goes on the bottom, then plus 2. So plus 2x. We integrate that, and then we've got the plus c there. So then we've got to simplify this. So 2 times 3 over 2 is going to be 3, so that's going to be 3x to the 3 over 2 over 3. And again, it doesn't matter if we do an extra line of workings to simplify it, as long as we're confident with our answer. Minus 9x to the power of a half over 2 plus 2x plus c. So then, if we simplify that final time, we get um, f of x. And there's no rhyme or reason why I'm swapping colours, by the way. Don't think that means anything in particular. That's going to be x to the power of 3 over 2 minus 9x to the power of a half over 2 plus 2x plus c. And then what we need to do is we need to substitute in y as 9 and x as 4. So we've got 9 equals 4 to the power of 3 over 2. So the way we do 4 to the power of 3 over 2, we deal with the bottom part of the fraction first. That's going to be the square root of 4. And then we raise it to the power on the top. So square root of 4 is 2, raised to the power of 3 is going to be 8. Minus, and we've got 9 times the square root of 4, so that's going to be 9 times 2, which is 18, divided by 2, which is 9. Plus 2 lots of 4, which is going to be 8, plus c. So that's going to be 8 plus 8 is 16, take away 9. 16 take away 9, which is 5 plus c. So we've got 9 equals... oh, sorry, it's 7, isn't it? Sorry, my fault. 7 plus c. So c is going to equal 2. So then what we do is we'd rewrite out our equation again, just replacing c with 2. So f of x equals x to the power of 3 over 2 minus 9x to the power of a half over 2 plus 2x plus 2. Hooray. Now the final 5 marks. Point P lies on the curve. Now the normal to P is parallel to this here. So again, if it says that it's parallel to that line, we're going to get a mark for working out what the gradient of this line is. So 2y equals minus x, y equals minus a half x. So therefore the gradient of the normal is going to be minus a half. Now if the gradient of the normal is minus a half, the gradient of the tangent equals the negative reciprocal. So you turn it upside down and change the sign. So the gradient of the tangent to the curve is going to be 2. So what we've got to do is we've got to find the x-coordinate, and the gradient is 2. So what we've got here the gradient function. So we've got to set the gradient as 2 and then solve it. So let's do just that. Let's set the gradient equal to 2. Let's see if we can solve it. So 2 equals 3 root x over 2 minus 9 over 4 root x plus 2. So nicely, if we take away 2, we're left with 0. So we've got 0 equals 3 root x over 2 minus 9 over 4 root x. So we're going to bring this over to the other side. So we get 9 over 4 root x equals 3 root x over 2. They're going to get all the x onto one side, so we're going to bring this up to this side. I'm going to bring this up to this side. And if we do that, we get 18 equals, okay, 4 times 3 is going to be 12. Root x times root x is going to be just x. And then we divide by 12, so we get x equals 18 over 12, which if we simplify dividing through by 6, we get x equals 3 over 2. And that is our x-coordinate of P. If it asks us to find the coordinates of P, we then need to substitute x over 3 over 2 into our f of x, which we worked out in part A, but it doesn't. It just asks us to find the x coordinate of p. So let's just double check that we've got that. So yeah, that's what we've got beforehand. The gradient of the normal is minus half, the gradient of the tangent is 2. We then need to set that equal to the gradient function. Blah de blah, we solve it and we get x equals 1.5, which of course is 3 over 2. So there you go, in just under an hour, that was the C1 paper. And I went through with explained stuff as well. So just goes to show there is plenty of time that you can go back through and just double check any answers. Okay, boys and girls, good luck.